So, hello and welcome everybody to Friday's special edition. Today we're going to be talking about industrial machine vision applications with Markus Schatzl. My name is Chris Armbruster. I'm the director of data career at the AI Guild, and precisely with me is Markus Schatzl, who is the innovation lab director at Sensework. Hello, Markus.
Hi, Chris. Good to see you.
So, hello and welcome, Markus. You are in the field of data and machine learning. It says you're an innovation lab director.
Yeah.
I would like to take our audience back a little bit in time, so to speak, and invite you to say how you arrived where you are. So, when did you get interested in data and machine learning? What was your path into the industry?
I joined very or relatively early into the machine vision industry about 2007 and was a machine vision engineer for more than 10 years. 2019, I changed to Sensework, where we decided that we have to sharpen our focus in the machine learning, deep learning sector and want to just deepen our expertise in this field. I got to say that classification tasks, like you find them in deep learning models right now, are very common in the machine vision application field for, well, also I would suggest more than 10 years.
Okay.
These were all approaches that worked by using support vector machines, but were quite reliable. So for us, it wasn't a thing that was so extremely new, but there were a couple new approaches like semantic segmentation that looked very promising to us at the time.
Okay, thank you. So you actually said you started in 2007 as a machine vision engineer. So hello, veteran. And you made some interesting comments, so to speak, about this perspective over the last 15 years, because that's what it is, 15 years. So following up on this, if you look back at the last 15 years, and I want to ask you this question about continuity and change. So do you have an idea in your mind in terms of continuity, what stands out over those 15 years, and then also what might be the big change that you've seen?
Do you mean with respect to machine vision in general, or with
Yes,
software applied to, or algorithms applied to images?
both, so to speak. So, I mean, you've been in the field for 15 years. So, to your mind, what's the continuity and what's the change?
I think the continuity and, well, fixed star is the image acquisition engineering, at
Okay.
least in the field of, well, machine vision applications. Uh, you kind of need some device to acquire your data, and you usually want to shape your data in a certain way because you have some intent, you intend to extract certain information from it. This is pure hardware if you want, and I don't see any way that this will change soon. So I
Okay.
think that's really a fixed part. What's well, where we see a shift is the algorithmic aspect of it, uh, where we had in the past quite some applications that were not realizable because they were too complex uh, and have been, well, left alone because mm, even our customers said, okay, we realize it's not doable or it's too expensive. We find another way to get around it. Often these applications are those who can be solved with deep learning or machine learning approaches right now. So there's, let's say, subclass of machine vision problems that weren't accessible in the past that are now, I wouldn't say easily, but they, well, solvable
Okay.
for us. Uh, and this opens up a whole new perspective on it. On the other hand, we see that machine learning is nothing without having all the seasoned algorithmic approaches at hand that have grown in the machine vision sector in the last 30 years. So
Okay.
it's always, for us, it's always a combination that leads to success.
So bringing, understood, so bringing, the elements around data acquisition, image acquisition, that are continuous, then also actually everything that's been learned in the field over the past 20 to 30 years, as you mentioned, and then the increased power of newer algorithms perhaps to deliver solutions. Which brings me to the
Sure.
follow-on question. So it says here, innovation lab director at Sensework. It doesn't actually say any engineer, and innovation kind of has this notion of doing new things, right?
Yeah.
So two questions actually. Let's start with, first tell me what does Sensework do, and then I'm going to ask you what the innovation lab does. So what does Sensework do, so people have a context?
Sensework is a pure machine vision company. We supply turnkey solutions to industrial customers, which cover the whole process of industrial machine vision, which essentially means well, a vertical solution down from light barriers or electronics up to the software. So
Okay.
we're 26 people, mainly located in Burghausen, which is near the Austrian border in southern Germany, uh, where we have machine engineers, computer scientists, uh, and all other kinds of technicians. So we're very engineer heavy in general. Then we have one office in Johnson City in the USA, and one other in about the middle of Germany. And finally,
Where in the middle of Germany? What do you consider the middle?
near Bonn.
Okay, but the Middle
Yeah,
West.
Middle West. Okay, let's say Middle West. And then we have our innovation lab here in Munich at the Ostbahnhof.
Okay.
And the innovation lies also within the fact that we're in our agenda, or from our agenda, we're we're regularly participating in scientific calls. For example, with the Fraunhofer Institute, with the KIT, and other scientific organizations with which we develop technical novelties in the field of machine vision.
Understood. So this is this part where the innovation lab comes along and where you're the director. Yeah. So you're searching for novel approaches.
Yeah, sure. So, but of course, we're very focused on the machine vision part. Not
Can you give
only
it?
the technical one,
Mhm.
but also things like how can uh, a machine vision software system be used in an ergonomic and user-centric way.
Could you give, so if you look back at the last 2 to 3 years, could you give an example of something that you really liked?
Yeah, what I like very much currently is one project where we are applying machine learning on 3D, not only on a lab setting, but really in line in the production of electronic vehicle models, uh, which is it's still a project that's not safe to work out, to be honest,
Okay.
because uh, doing or assessing 3D data with neural networks seems easy or well doable in the lab, but it's much more complicated if you really are in a production line and have to get that huge amount of data safely analyzed. So it's always not just about can I prove it at the lab, because that's mostly doable for all of the stuff that comes along here. But the question is, can it be done in a certain amount of time? Can it be done with the resolution our customers need to have, or the application needs to have? can it be done in time? Can it be handled? Are the devices available at all to
Okay.
get the data?
Okay.
Yeah, so there are much more practical aspects in it than just the core software solution.
Understood. Or let me actually check whether I've understood it. So you mentioned a couple of things that I roughly imagine as follows. So it's applicable to an industrial setting in which somebody has a factory in which there's one or more production lines. Is that right so far?
Yes, that's more or less yeah the rough frame that you have
Okay.
an automated industrial task, usually a quick one,
Hmm.
which has to be monitored. Uh, yeah, and
And three-dimensional sensing means that there, for example, the production line produces something. There's an output that has object characteristics, and you are
yeah,
doing 3D sensing collection, data collection on that.
yeah, we developed a particular sensor for it with a tandem laser triangulation setup where
Okay.
we create a 30 micron 3D representation of those welding seams, for example.
Understood. So you actually, so I mean, there's data collection, there's algorithm, but you also mentioned the sensor. So you also, this is custom built hardware.
This is semi-custom built hardware. We are
Okay.
working very close with our suppliers,
Okay.
so we know the hardware very well.
Okay.
So we approach our suppliers and tell them what we would need, and they tell
Okay.
us if they can build it,
Okay.
and then we assemble it the way we need it in our engine. Yeah, in our workshop in the end. So we're also
Very cool.
at Sensework. We're doing the machine engineering as well.
Understood. So, okay. So now you mentioned at the beginning that you provide turnkey solutions, and now I get the picture actually.
Yeah,
Okay. Thank you very much for this. Yeah. So, turnkey actually means that somebody can come to you and say, we have something that we think is suitable for an industrial machine vision application. And
sure.
you can come in and actually, if need be, set up the hardware, put the software behind it, collect the data, and then help them to understand what is going on. What would be a typical use case or outcome in which this would be particularly meaningful for a company?
Well, there are so many that it's really difficult to say what would be typical. But if you take some let's say toothbrush or
Okay.
or shaver blades or something
Hmm.
like that, so which are produced and have to be quality assessed. And it's not only interesting how the surface looks like, if there are errors in or have been errors in the in production in producing them. So let's say uh, well, lacking blades or lacking material in some way, functional errors. So you typically have checking tasks and measurement tasks.
Okay.
So and all of these objects come along unsorted. Let's assume a typical rate by 10 parts per second.
Understood. Okay.
So and you're somewhere in between, and before they're packaged, they're yeah, high speed assessed uh, to deliver. That's a term that's very often used in this sector. Deliver 100% quality. So that's the idea behind machine vision, in particular in industry.
To some extent, in this example, what you do is you spot kind of faulty products, and as a customer, I'm lucky I don't get them. Um, um, if you're spotting faulty products, does that also mean you can help customers, you can help companies then understand how to change or improve the production process so that the scrap rate or waste rate goes down?
Well, in theory, yes, of course, because
Okay.
if we measure the size of a product or count something or generally quantify something, we record that, of course, and we can graph it and can analyze it afterwards. And,
Understood.
well, of course, to a certain extent, uh, you can, yeah, you can just use that data uh, to check where these errors actually come from. Yeah.
And improve the
So,
process. Okay, that actually, so to speak, for today brings me on to the final stretch. So, the reason why we're speaking today, and it's shown at the top, is the Data Lab Summit that's happening in Berlin from the 22nd to the 24th of June, and you will be speaking and presenting your company, your work, but also your use case. And it'll be on 23 June. It's called AI in Industrial Machine Vision Applications. And actually, I wanted to take the opportunity to invite you to, so we've been speaking about factories, about production lines, about machine vision. You've also highlighted that there's a 30-year tradition of doing this. Um, can you say a bit more about machine vision? So, and and also in the context of the popularity of, say, computer vision as a buzzword. So, do you see what's the difference for you between computer vision and machine vision, and where's machine vision today?
well, I'd say that well, computer vision is well slightly older than machine vision, but not so much. Machine vision is a well-established industry existing for roughly 35 years now, maybe a bit longer, and well, generally means the practical application of things that yeah, of ideas from computer vision uh, with the help of artificially made images, so camera images, not just the scene before in front of your window with a kind of natural scene, but something that's intended to be analyzed in a way. So
Okay.
this can be, well, an industrial automation task, but this can also be a scientific application, observing something over a very long time, analysis in labs, or cell analysis, sorry, uh,
No problem.
and stuff like that. Yeah, computer vision. Uh, well, is the well the university part of it, I'd say,
Hmm.
the purely scientific part.
Okay.
One interesting thing I observed over the time where I'm in this industry is that they are kind of passing like ships in the dark. So they use the same matter to move,
Hmm.
but they rarely meet each other. And often I see that there are things that coming out of university that are considered to be novel, which are in reality in in application for 20 years, like some machine learning applications right now. On the other hand, there are problems on the machine vision side, which have been solved a long time ago in the computer vision area. So it
Interesting. So, I mean, I'm, what my brain is working on you on this metaphor of ships in the dark passing each other. Yeah.
mm,
I haven't heard that one before. That's actually really interesting because you're saying, I think what you're saying is the fields are actually related. We could even discuss whether they're intimately related, but I think you're also suggesting, if I got it right, that machine vision has a strong practical industrial kind of background. Computer vision is more, well, it's also old, but at the moment is more scientific, university oriented, and they don't talk enough to each other.
yeah, that's what I see, at least.
Cool. Okay.
And one thing that's yeah, that's very special to computer vision is the the basic data are some kind of standardized data sets usually. So this is the lowest interface. Let's put it like that. on image data. In machine vision, uh, the whole part of creating that data representation is part of the game. And this also makes a difference because often you can, yeah, you can still extract information out of things with particular specialized camera techniques, illumination techniques, filters, wavelength, and so on, which are just not well retrievable by standard camera equipment.
Okay.
And this opens up the field very wide.
Okay. Interesting. Thank you. Um, to I want to do a final loop. So the presentation or the title that we're looking at here is AI in industrial machine vision applications.
Mhm.
And I wanted to invite you to switch perspective for a moment. So if we fast forward to the 23rd of June, and I was going to come to your talk, or somebody is coming to your talk, what could they expect? And do you already know perhaps what type of examples you would give around applications?
Uh, I'm not I'm not finally sure which one I'll bring with me. Maybe I bring two to
Hmm.
because it's really a very broad field of application. Uh, but I think it's valuable to see the whole vertical process of how such a machine vision application looks like in its architecture, because usually protagonists from the DLML world only look at the top 10%, I'd say, and this is often not enough to to get into the machine vision world and successfully find customers who buy your software. So I really want to help improving the understanding of how machine vision works, and of course, I also want to introduce our software Neuralize, which is a tool that sits on top of our Vision Commander software that allows plugging in neural network models, whereas the
Okay.
whole software below it uh, has all the interfaces implemented that you need for typical machine vision applications. So like PLC communication, particular protocols, camera integration, IO board communication, so databases and so on. So the whole what's called Maschinenraum engine room
Okay. The
below
engine of it, so to speak.
uh, that you not necessarily want to know or need to know if you're a specialist for creating deep learning models.
Understood. Okay, thank you. So, if people coming to listen to you, well, if I got understood correctly, on the one hand, kind of get a broad overview, and you have this background in machine vision over very many years. So, in the industry for 15 years, as we've learned, then your company's active in this, and also you've actually developed a new product that you just introduced called Neuralize that I guess does this better and introduces neural networks to those tasks. So that's what people would be getting, I hope.
Yeah, that's true.
Okay, then actually for today, Markus, thank you very much. Thank you for joining me online. I look forward to seeing you in Berlin in 4 weeks. Um, Thank you very much.
Yeah, thanks for having me. Thank you very much as well. It was very nice talking with you today.
Thank you.